20-1s. Here we go. Let's keep working through word problems. Last day, we took a look at the distance problems. Today, we are going to look at rate of work problems. Page 17 of your booklet. First of all, rate of work problems. What we are looking at with rate of work problems is we will have worker 1, worker 2. It might be items that are doing the work. It's not always people, but it's objects, people that are doing work. First person, first thing, does a job. The second person or thing does the job. What happens if they can do it in, number one does it in so much time, number two can do it in so much time. What happens if they work together? How long does it take if they work together? That's what this is all about. So, please understand, first of all, when things work together, they work efficiently. If these questions involved my sister and I growing up, it would take me so long to do a job, it would take my sister so long to do a job, and when we worked together, it would take 10 times as long because we would do nothing but fight and argue about things. These objects always work efficiently together. So, rate of work problems. Couple things that are important. Time to complete a job before we get into an example. Time to complete a job is the first thing you're going to fill in. Let's say it's 5 hours to do a job, whatever it is. Paint something, fill a pool with a hose, who knows? Well, the rate of work that you work at is not how many hours it takes to do a job, but we want to know with rate of work, we want to know how much gets done per 1 unit of time, whether it's 1 hour, 1 minute, 1 day, 1 week. So if a person takes 5 hours to do a job, how much of the job are they doing per hour? Well, they're doing 1/5 of the job per hour. That's what the rate of work is. The amount of work done per unit of time. Another situation, it takes a company, I don't know, 6 weeks to complete a job. What's the rate that they're working at? Well, this would be how much is getting done per week. If it takes 6 weeks, they're doing 1/6 of the job each week. 1/6 and 1/6 and 1/6 and 1/6 and 1/6 and 1/6 over the 6 weeks becomes one full job. So that's what we're looking at for rate of work. Now the last part, the amount completed together. This is where we start to create the equation. Because if I'm working with someone, how much do I do of a job? Well, if it takes me 5 hours to do a job and I'm working with someone, I'm not going to do 1/5 of the job. How much gets completed? The amount is equal to the rate that I work at times the time that I'm working for. So I get 1/5 of the job done every hour. But if I'm working with someone, I'm not going to work for 5 hours. I'm going to be working for something less. So the rate times the time is the amount that gets done. In this case, if I was doing 1/5 of the job per hour and I worked for 3 hours, I would have completed 3/5 of the job. I wouldn't have done the whole job because it takes me 5 hours, but because I'm working with someone, it took us 3 hours, so I've done 3/5 of the job. All right, so that's what these questions are all based on, this ideology. The last bit before we jump into it, time together. So here's time to complete, and together, this is usually going to be our X. Not always, but a lot of the time, it's our X. We don't know how long together. That's what we're going to be calculating. And the amount that the first person does, like I just showed you, it was 3/5. The amount the second person does, and maybe there's even, sometimes there'll be 3 workers or 3 objects, but your equation is always going to be this. the amount the first person does, the amount the second person does, and it will always equal one finished job. Your equation will always equal one job. I do 3/5. My partner then would do 2/5, and together we'd have finished a job. So this is the equation we're going to use every time. Let's walk through two examples. These ones aren't quite as involved as the distance problems, so hopefully we'll get her down a little quicker. So page 17. Susan can paint the garage in 5 hours. Her dad takes 3 hours. Is that because he works faster or because he doesn't care and he does a bad job? We'll never know. However, we want to know how long it takes them to paint together. So we have the two people, our dad, well, and Susan, either one first, doesn't matter. So dad, how long does it take dad to do the job? It takes dad 3 hours. So how much or what rate is dad working at? How much does dad get done per hour? He's getting 1/3 of the job done per hour. All right. Susan, we know, takes 5 hours to do that job. Well, what's the rate that Susan's working at? Well, Susan, how much does she do per hour? She gets 1/5 of the job done per hour, because 1/5 for 5 hours becomes one whole job. What are we trying to solve? We're trying to figure out how much time together does it take to finish the job. Well, let's finish the chart. How much of the job does dad do when he works with Susan? Well, like I said, this amount is based on the rate times the time. Well, we know dad's working at a rate of 1/3 of the job per hour. How long is dad working for? He's not working for 3 hours because they're now working together. And together, time, we've called x. So 1/3 times x, I can write this as x over 3. Because it's like having x over 1. 1/3 times x over 1 is x over 3. There's the amount that dad's going to do. Susan's doing 1/5 of the job per hour times how many hours? Well, we're not sure because she's working with dad and we don't know what that is. But if I multiply 1/5 times x over 1, we can write it as x over 5. So what's our equation? We just talked about it a couple minutes ago. The amount that dad does, which we have called x over 3, plus the amount that Susan does, which we've called x over 5, always works out to be one job. And in this case, it'll be one nicely painted garage. So there's our equation. Same routine each time for rate of work. The amount that dad's going to complete plus the amount that Susan's going to complete will be one nicely painted garage. And now we solve. Well, we're back to rational equations, which means get rid of your denominators. 3 and 5, what's your common denominator? It's 15. Well, and I could look at it. I'm going to multiply by 15, multiply by 15, multiply by 15. If I have a 3 and a 15, I can cancel the 3, which will leave me with a 5, and I have 5x. 5 and 15, I can reduce by 5. That becomes a 3, so I have 3x, and 1 times 15 is 15. Combine my like terms, divide by x, and x works out to be 15/8. But what does x represent? X is time together. So time together is 15/8, or if I put it into decimal, because we don't usually talk time as a fraction, it would be about 1.9 hours. Now, it was 1.875. Please don't say 1 hour, 88 minutes. That's not what the decimal is. This 0.875 or 0.9 is that much of an hour. So it would be 9/10 of 60 minutes. Just leave it in this form. 15/8 or 1.9 hours. So it's going to take them just under 2 hours to paint together, which is 1.9 hours. Does that make sense? So many students I find when they see this, well, I'll just average 3 hours, 5 hours, that's 4 hours. Together it's 4 hours. That doesn't make sense to just average these. If dad does it alone, it's 3 hours. So together it has to be less than 3 hours. And that's what we got, 1.9 hours. Here's the second one. Maybe stop the video, give it a try, and then we'll talk as a group. So here we go, shoveling the driveway. Sunita takes 75 minutes. Her sister Sushila takes 50 minutes. So we have Sunita and we have Sushila. And they're shoveling the driveway. So time to complete. Sunita does it in 75 minutes. Well, what does that tell us? The rate of work, how much is she doing per minute? She's doing 1/75 of the driveway per minute. Sushila takes 50 minutes to do the driveway. So Sushila's doing 1/50 of the driveway per minute. All right. Finish off the chart. What do we want? Together, how much time is it taking? There's our X. How much do they each complete? Well, remember, amount completed is rate times time. Sunita does 1/75 of the job per hour for an unknown number of minutes because that's what we're trying to calculate. So we can write this as X over 75. Sushila, same thing, 1/50 of the job per minute for X amount of minutes when she works with her sister. We don't know, but we can call it X over 50. So now we can go to our equation. Our equation, the amount that Sunita does, X over 75, plus the amount that Sushila will have done, X over 50, will equal one nicely clear driveway. And now we solve. Rationals, 75 and 50, common denominator. We need to multiply the whole thing by 150. So we're going to multiply by 150. Cancel the 75 and the 150 becomes a 2, so we have 2x. Multiply by 150. Cancel the 50, 150 becomes a 3, so we have 3x. Multiply the 1 by 150 and we get 150. So in this case, 5x equals 150, so x works out to be 30 minutes. So the time together is 30 minutes to clear the driveway. And there you go. Working together. Rate of work. A unique situation follows a pattern. And there you go. So what we have here, assignment, textbook, a few questions out of the textbook, and then you have the word problem worksheet from last lesson. 1 to 5 was assigned. Basically now the whole thing. I think it's 1 to 8. Now please understand a couple questions in this assignment aren't distance or rate of work. A couple of them are general thinking, read carefully, and set up by thinking about what the question says. They're manageable. They're tricky, but manageable. Give it a try. Seek out some help if you need it. I love talking math. Enjoy.